Hi everyone, we'll start shortly. Hi everyone, welcome. Thanks for joining. My name is Gary Taylor, and today I'm going to run through the latest updates on the Megaport MCR, or Megaport Cloud Router. This is part of the ongoing series of Megaport Live Tech Drop-ins. Megaport is a networking as a service provider. Essentially, we provide the ability for customers to consume networking services in exactly the same way you would consume cloud services. So real-time, scale up, scale down, delete, migrate, etc. So what makes Megaport platform different? Well, firstly, the reach. Megaport NAS is part of a virtualized global ecosystem built on pre-existing hardware. This gives you the ability to deploy capacity to all of the well-known cloud service providers, giving you access to thousands of IT-based services, as well as connectivity to other data centers and IX services across the globe. It is predictable performance. It's like having your own private fiber lines, making it highly secure. Your data travels on our private global network with no internet within the core. All these components can then be linked together using virtualized network cross-connects, which we call VXCs, or virtual cross-connect. And they are typically layer 2 MPLS pseudo-wires. And as stated, this can all be done in near real time, just a few minutes and the service is up. You only pay for the capacity that you wish to deploy. As it's all pre-built and virtualized, you can scale that capacity up and down on demand. You no longer have to worry about traffic spikes or wasted capacity, and this ensures good end-user application performance. This makes NAS very cost-effective. This can all be designed, deployed, and be fully operational in minutes and be available for only the term you need. This reduces your upfront infrastructure cost to zero. Also, your time cost is zero, as your Megaport assets are virtual and require no capital investment or hardware provision. It's also worth mentioning egress fees for all cloud providers via Megaport partner on-ramps are significantly lower. So there's a potential data cost saving element when using private cloud access. So you can design, deploy, manage, and monitor all on a single secure portal. It's point and click. You bring your cloud server keys, and this makes establishing private connectivity simple. We also provide full API integration and Terraform integration as well. So we spent more than a decade building a truly massive global network across 1,000 data centers, over 400 service providers, and 26 countries. We've deployed kits in sites around the globe, physically interconnected those sites, then established NNIs with hundreds of service providers, including the hyperscalers like AWS, Azure, Google, and Cloud, Oracle Cloud. Over the top of that network, we've deployed a customer software layer that gives you complete control over the network using our web portal or via code using Terraform or API. So this map is representative of the network we built. Obviously, not every POP is included and every physical route is included in this map. Just a quick overview of the options that are available. On the left, let's get my thing here. There we are. Yeah, here we are. On the left, we have hybrid cloud. This is where you connect your infrastructure in the data center to Megaport via a cross connect. And then capacity here is from 1 gig up to 400 gig ports. We then have a virtual POP feature. This is an on-demand network function virtualization. Here you can deploy SD-WAN gateways, virtual routers, and virtual firewalls in minutes in real time in over 90 locations globally. Then on the right, we have cross-cloud, and that's where you spin up a virtual router, and that handles traffic between 2 or more clouds at the edge. And then in the demo portal, I will run through some of the latest features of the MCR. So yeah, quickly over to the MCR now. Just here we go. So what I've done here, I've actually created the MCR as and is delivering services as a multi-cloud VPN gateway. Before I jump into what I've actually designed, just to show you quickly, obviously we've got prefix filtering. That's not new, and I've been doing a lot of prefix filtering just for the services here. If I just jump into that there. And also the dark theme, that's one of the new features. It's very good, much easier to read. So that's prefix filtering. We then built packet filtering. So essentially access control lists. And here what you can do is you can actually further harden and strengthen the MCR by locking down traffic based on source and destination IP address as well as protocol. So this does give you the ability to, significantly enhance the security offering. It's not a firewall, it's not a stateful firewall, but when you're running, say, IPsec, which we'll come on to, you can then run the ACLs into the MCR. And then obviously if you're connecting to a cloud or connecting to on-prem, there would be firewalls within that cloud region. So you have highly advanced firewalls typically sitting in a landing zone. So we just basically add additional security, and then the full security is delivered at the cloud. So going back, as I mentioned, this is a multi-cloud VPN gateway. I've set up a resource in Amsterdam. I've delivered private connectivity to AWS. And obviously, just to represent the cloud topology, I have an internet breakout. And that internet breakout is running multiple IPsec sessions for branches or offices connecting into the MCR. And then it's also acting as a backup to the primary connectivity. And then what I've done here at the bottom is to simulate an on-prem environment. I've stood up a virtual edge, so a Megaport virtual edge, 2-core device, Cisco device, sitting in Stockholm, and I've connected privately back to Amsterdam. And then I'm just running a small internet breakout for the management of that device. So this is just really to simulate the on-prem environment. So if we look at, obviously, the key feature that we've added is IPsec, and we can do IPsec on internet gateways. We can do IPsec on any VLAN connected to the MCR. And in this case here, what I'm doing is I'm running IPsec for my home office, connecting into the MCR. And then the MVE is our simulated on-prem environment. We have a VXC going privately. And the whole idea is that if that VXC failed, I will then connect into the MCR via this service as well. And then if and then from there, I would connect privately into the MVE via an encrypted tunnel. And then IPsec, this is just the AWS connection, and that is just an external VPN tunnel running into AWS as well. So going back out here, from my side, that is pretty much it. The multi-VPN cloud gateway works. It runs multiple BGP sessions. You run 10 IPsec tunnels per package, and the package is obviously chargeable for every MCR. And then what I'm going to do now, just before we finish off for the day, I'm going to run through some of the BGP sessions that are built. As you can see here, we have a connection to AWS. That is a private direct connect, connecting into direct connect gateway, and that is encrypted as well. And this is the encrypted tunnel, so 169 address, connecting back to the transit gateway within AWS. And that is connecting on the same physical, virtual VLAN or VXC. And how I've done the weighting is I'm saying choose the 169 address, the encrypted session as the preferred route. So all the traffic is encrypted. And if that fails, we'll then go encrypted over the internet IPsec tunnel. And that is here, and it's not up. I've just configured something incorrect. So I just need to fix that as well. But as you can see, they're both connecting back to the transit gateway in AWS. And then for the same thing here for the MVE, what I've done is I've connected privately to the MVE here, 192 address. That's my Cisco ASN ID. And then I've done the same thing. I'm encrypting that session. I'm going on a 172 address here into the same ASN within the MVE. And I'm saying choose this route as a preferred route. And if that fails, we'll connect over here, which is going back to 65001. If that fails, we'll connect over the internet back into the MVE. And then just to show you some of the details here, what we're doing here is we are advertising subnets into AWS. And then from AWS, we're receiving the 10.2 range, which is our VPC. And also we are receiving the 172.16, and that was the outside address that AWS assigned to the IPsec tunnel. So we're advertising that into the MCR, and that allows us to bring up the tunnel. And then this is just the 169. This is the IP address advertisements into AWS, and it's over the IPsec tunnel, but that is running obviously on the private direct connect. And then here we've got the 172, and that is the encrypted tunnel back to the MVE. We are receiving a 192.168.20 range from the MVE, and we're advertising that out. And then that's the encrypted tunnel. And then here is the standard unencrypted tunnel for the MVE service. And then as you can see here, we then have the encrypted tunnel for the backup for the MVE. And that can just, that could be an MVE literally, or it could be your on-prem environment. And we have 3 tunnels running here, or 3 sessions running, BGP sessions running for that MVE service. So that is it from my side. Obviously, any questions, please send us a message, and we look forward to you on the next session. Thank you.